Okay, so good evening, everyone, and I welcome you all to today's live session. And this is the week 10 live session for the course Nonlinear Vibration, NOC24 me54. And this course is being taught by Professor S.K. Dwivedi of IIT Guwahati. And I'm Rashia Diti Ranjan. I am a NPTEL PMRF TA, and I'm also a PMRF scholar in the Department of Mechanical Engineering, IIT Patna. So we have already completed 9 live sessions in which we discussed about certain questions related to the course which is being taught, which would help you to finally solve the assignment problems. So I'll start by a brief overview of what has been taught this week. So this week was basically focused on the vibration reduction techniques and what is the need and what are the type of vibration reduction techniques. So coming on to that, what is the need of vibration reduction? So when we talk about mechanical systems, there are certain cases wherein vibration is introduced in the system, that too unwanted vibrations. For example, if I talk about a car that is traveling on a bumpy road. So, as you know, that suspension system are introduced in a vehicle in order to reduce the vibration at the vehicle, which is due to the traveling of the car on the road, which is uneven, right? So that is why reduction of vibration is needed. Second example could be the machines, like even the big machines and the smaller machines. Like for example, if I talk about washing machine, which is used in a household. So if you know about the washing machines, which used to come earlier, which was not automatic. So there was this drainer, which it had a drainer. So when we used to put clothes in it, it was necessary that the clothes were distributed evenly in that tub, right? If the clothes get segregated towards one side, then you'll see that the washing machine would start vibrating. It will start jumping, okay, which is because of the vibration, and that vibration is not wanted. It happens because of the eccentric loading, right? Like for example, if let us take a top view, if this is the top view of my tub and this is my axis, and if my mass is somewhere over here, so see if it will start, all the mass is segregated over here. So it will start producing vibrations, right? Because of which the machine will experience vibrations. Now you can also see these in various big machines as well, which are used in factories and everything. So if you people must have noticed that those machines, they have a rubber kind of a support at the bottom of them, which is used in order to stop the transmission of the vibration that is being produced by the machine on the floor. Okay, likewise, there are various examples. So that is the need that the vibration should be suppressed in order for the proper behavior of the system. Okay, so there are various types of vibration reduction techniques. Okay, we have vibration isolation technique, then we have the vibration absorption technique that I'll cover in the further slides. Apart from that, there are passive and active vibration absorber, which may have a time delay, and feedback as well. Now, when I say time delay, what I mean is that there can be some time which the machine or the actuator takes in order to actuate. Like, for example, if I apply force on an actuator, okay, so in order to transmit that force, it may happen that if it is a elastomeric body, it can take time to actuate, though it can be in milliseconds, but still it takes time. So it may happen that in some cases we need to consider this time delay, because see, if a machine is in the verge of catastrophic failure, it is very important that at the particular instant when the failure is going to happen, we have to provide a counterbalance force so that that catastrophic failure can be prevented. Okay, but if even if there is a time delay in milliseconds, it will cause the system to fail. Okay, And there can be different type of feedback as well, like we can measure the displacement and then provide the force on the basis of that displacement. We can measure the acceleration and then we can provide the force on the basis of that acceleration. Okay, and then effect on vibration reduction of control and damping parameters. There are various parameters that can be used, right? So in the system, and what are those, the effect of those parameters is also discussed. Okay, so this is all about the overview. Now I'll come on to the questions. Okay, now see, question number one. Which of the following is used for vibration reduction? Now see, firstly we'll have to understand that what are the types of vibration reduction, right? So vibration reductions can be, firstly, where is it used? It can be used in any engineering structure, washing machines, vehicles, motor system, anywhere it can be used, wherever excess, some kind of vibration is produced which is not required. Okay, unnecessary vibration. Okay, which actually reduces the efficiency of the system and everything. Okay, so firstly, we'll talk about the types. So firstly, where it is used is it can be used for any engineering structures. Okay. Okay, so it can be used for any engineering structures. Okay, Sachin, am I audible to you?
Yes, madam.
Okay, fine. Okay, so we'll talk about vibration reduction. So as the name suggests, vibration reduction basically means reducing the vibration. Okay. So, or mitigate the vibration. So it is divided into Broadly, it is divided into two categories. One is the vibration isolation, and second one is the vibration absorption. Okay, so there are two things: vibration isolation and vibration absorption. So, as the name suggests, one basically deals with the isolation of the system from the surrounding, and the second one deals with the introduction of some coupling inside between the system and the surrounding so as to mitigate the vibration, right? So if I talk about vibration